Welcome students. In this video I am going to discuss about types of functions. Okay, and here I will take some important functions. We'll discuss that functions graphically. Okay, means what would be the nature of graph, okay, or how to represent that functions graphically. Okay, that one we'll discuss here. And these functions I am taking very important functions which will be needed. Okay, so already I have told you the definition of function. Already I have told, if you are having two sets A and B, suppose in the set A you are having the element x and in the set B you are having the element y. Now what I have told about the definition of function, already I have defined. So function is nothing but, function is a rule. Function, suppose f is the function, function is a rule which maps each element of A to a element in B. Okay, function is a rule which maps or which relates the elements of A to a unique element in B, that one I have told. That means suppose x is the element in the set A, so in the element x, if I use the rule f on x, that means if we use the rule f on x, then we will get y. At that time f is said to be the function, and we'll call y equal to fx, and we'll call that we'll get y by imposing f on x. So we'll read this one as y equal to fx. Okay, this is the definition of function. In my last video I have told. Now what type of function are there, what type of functions are there, that one we'll discuss. Okay, so mainly there are so many functions, so many types of functions are possible. Okay, but here we'll take some standard functions, okay, of which graphs are very important. Okay, suppose first one we'll discuss here, that is called identity function. Okay, identity function, the name of the function is identity function. I'm using the notation like this to represent function. Okay, so first one is identity function. Then second important function that we will discuss in this video, that one is called constant function. Okay, I'll discuss all the things in detail, okay, graphically. Then third one is identity function, constant function. Then we'll discuss about modulus function. Then we'll discuss about signum function. Then the last one, that one we'll discuss here, that is called very much important, that one is called greatest integer function, that is GIF, greatest integer function. So these 5 functions I'll discuss here with their graphs. Okay, so let us start quickly. So first one, that one will discuss identity function here. So how we'll define identity function? Let me write the definition first, then I'll draw the graph. Okay, so the definition of identity function of x. Here I'll take the variable as x, so I'll tell function of x. Okay, function of x, the identity function, that one is equal to again x. That means, this means that if you take the rule f on the element x, you will get again the x. It doesn't change at all. That kind of functions are called identity function. Suppose fx is y. No, I have already told y equal to fx. That means there will be y would be directly equal to x. That means the image and the pre-image, they will be same. Okay, because we have seen, no, there this one was x was the element of A and y was the element of B, and if I impose the rule f on x, then we are getting y. Now if this y is also coming x, means after imposing the rule f on x, if we are getting again x without getting y, that means we are getting again x. This x means there is no change in the x even after imposing f on x. So that kind of functions are called identity function. Identity function means which doesn't take any kind of change even if you apply f on the element. Okay, that kind of functions are called identity function. So always remember y equal to x or fx equal to x. Okay, both the things are correct. Y equal to x you can tell, or we can tell fx equal to again coming x. Okay, that's why these are called identity function which doesn't change. Okay, now it will be more clear if we see the graph why it is called identity function. It will be more clear. Let me discuss about the graph. Suppose this is the coordinate system, you know. Okay, this is the coordinate system. Now this is the point 0, this is the point 0, this is y axis, this is x axis, already you know. This is y, this is y dash. Okay, this is x dash. Now this is the origin 0. Now you take here, first of all I'll change the value of x. Identity function means even if you change x, y will not change, y will not change. That means that one will remain x only. Okay, you see how. Suppose I am taking in place of x, I am taking 1, so it will be what? F of 1, no? So in place of x I am taking 1, so f of 1 will come what? Again 1. That means y is coming 1, isn't it? If I take x equal to 2, so f of 2, so this one will be what? X is taking the value 2, no? That means if I change x, whatever change you are taking in place of x, y is taking the same change. Y is taking the same change. So from this part we can tell, if I take x equal to 0, if I take x equal to 0, y will be equal to 0, no? From here we can see. So y equal to 0. Now I am taking x equal to 1. This is the point 1. I have taken x equal to 1. So y equal to coming again 1. Y equal to coming again 1. So I will put 1 there. Suppose this is the point 1. This is 1. Okay. Then I am taking x equal to 2, then y will be 2, like means suppose this is the point 2, so there, this is the point 2. Similarly, suppose x equal to I am taking 3. Okay, so y will take 3, means like this, it will be somewhere here. In this way it will go on. Whatever the value you are taking for x, similar value it is taking for y, isn't it? And in the at x equal to 0, y is taking 0. Now take the negative values. Take the negative values. Suppose I am taking -1. In place of x I have taken -1. Okay. In place of x I have taken -1. So what I am getting? Again -1. That means y equal to -1. Isn't it? Suppose x equal to I have taken -2. So f of -2 would be equal to what? Again -2. Put the values here. Suppose I have taken -1. Whenever I have taken -1, y is also taken -1. Yes. Y is taken -1, so negative side of y, that means here, isn't it? For the value -1, y is also taking -1. For the value -2, for the value x equal to -2, y is taking -2. Okay, like this. For the value -3, y will take -3. In this way it will go here, so on, so on. Now if you join all the points, if you join all the points, this will look like this. Okay, this is the graph of identity function. Why identity? Even after if we change x, y doesn't take the change. Y is remain again the same. Means y is taking the change, same change it is taking. Whatever the change you have given to x, y is taking the same change. Okay, that kind of functions are called identity function. That means y and x both are taking the change same change they are taking together. Whatever the change you have given to x, same change is taken by y. Okay, that kind of functions are identity function, and this is the graph of identity function. Always remember, the graph of y equal to x will be always pass through the origin. Always pass through the origin. This is the straight line passing through the origin. Always remember, this one is very important. Identity function graph. What is the graph of identity function? Graph of identity function is just a straight line which is passing through the origin. Now let me go to the next function. That one was constant function. That one was constant function. So let us see what is constant function. Constant function means at that time fx would be equal to some constant value, any number. Okay, whatever change you take in x, okay, y will not change at all. Y will not change at all. Y will always remain the fixed. Suppose these are the things. Okay, suppose this is the suppose capital X, the domain, and this is suppose y. Okay, in the x I am taking 1, in the x I am taking 2, 3, 4. Okay, but for 1 also in the codomain I am getting suppose 10. For 2 also I got 10. For 3 also I got 10. For 4 also I got 10. Whatever change you take in the domain, okay, in the values of x, you will get no change in the value of y. That one always remain fixed. That one will always remain fixed. That's why it is called constant function. The function name is constant function. Already I have written constant function. Okay, why constant function? I think you have got whatever change I am taking in x, y doesn't change at all. That's why it is called for constant function. How to draw the graph? Let us see quickly. Very easy graph, this one. Okay, very easy graph. Constant function graph. You see, suppose this is the coordinate system. Okay, so whatever I have told, if you change in x, y will not take the change. Y will be same only. Suppose let us take one example. Let us take one example without c. Let us take one example. That was, suppose I have taken 2. That means whatever x I will take, y will always remain 2. I have taken in place of c, I have taken 2. That means y is 2. That means y will be fixed at this point. Suppose this is the 2. Now you change x. Suppose I have taken x equal to 0. So obviously if I take x equal to 0, there will be no change. No, it will be 2 only. Isn't it? Because there is no x. So that it can get multiplied and it became 0. It will remain 2 only. So in place of x I have taken 0, y is remaining 2. Now in place of x I will put 1. So there also, there means after then also y is remaining 2 only. Similarly, if you take x equal to 2, there also 2 only. Then f equal to, suppose minus 1 I am taking. Whatever you take, that one will be always 2. Whatever the x you take, the y will remain always 2. That one will be, if we draw here, for the value 1, y is 2 only. For the value 2, y is 2 only. You see, for the value 3, again y is 2. For the value 4, y is again 2. Isn't it? Y will always remain 2. Similar for the negative values. For the negative values also y will be 2. Okay, suppose minus 1 here I have taken. This is minus 1. For the value x equal to minus 2, this is also 2. For the value x equal to minus 3, this is also 2. So now what you are getting? You are getting y is 2 always, isn't it? I think this has gone something curved, but it is straight. Okay, at the value y equal to 2. So y is remaining fixed at 2, whatever change I am taking in x. This is 1, 2, 3, 4, minus 1, minus 2, minus 3, whatever change I am taking, y is always remaining 2, no? So that's why if I join the points, the graph will look like this. So constant function graph, y equal to c, or fx equal to any constant, will always look like this. Suppose I am taking fx equal to 3, at that time the line will be similar only, but it would be at the distance 3, at y equal to 3. Suppose I have taken in place of c, I have taken 10. So at y equal to 10, there will be similar kind of line parallel to x-axis. So this is the graph of constant function. Okay, so very easy. Next one. Next is our, what is that? Modulus function. Modulus function. Very important function is modulus function is very important. In calculus, there is a huge use of this modulus function. Modulus function. Remember the name. Or sometimes we call this one mod function. Okay, modulus function. Let me tell about this one. Fx would be equal to, modulus function is defined as, definition is a little bit tricky. Okay, fx equal to mod x. Fx equal to mod x. Obviously this is only y. Fx equal to mod x. Now what is the definition of mod x? You see, definition is like this. Mod x will be x. Mod x will be x if x is greater or equal to 0. Or let me write greater than 0. Mod x will be x if x is greater than 0. That means if you are taking the positive values, then if you take modulus, that one will remain the same. If x is less than 0, that means if you are taking some negative values in place of x, then it will remain minus x. The modulus of x, if you break the modulus, at that time it will be minus x if the values of x are less than 0. Now if x is taking the value equal to 0, modulus of x will be 0 directly. Okay, this is the definition of mod function. Very important function. You see, I'm giving one example. Suppose mod 5 I have taken. Now what would be the value of mod 5? Let us discuss. Mod 5, this 5 is positive or negative? Out of these three conditions, in which condition it is falling? X equal to 5, it is positive, that means greater than 0. So if you break mod, there will be only what? Simply x will be there. That means mod 5 will be 5. But if I take mod of minus 5, if I take mod of minus 5, see the condition. If x is less than 0, so here in place of x, what is there? Minus 5 is there. Minus 5 less than 0. So mod of minus 5 will be, here what I have taken? Minus of x. That means minus of x. What is x there? Minus 5. You see, don't get confused. So obviously it will be again 5 only. Whatever the values, positive or negative, if it is goes inside the mod, it will come out as positive. It will come out as positive. You may think that, sir, why it is minus? Obviously because x is itself negative. X is itself negative. So we are supposed to take one more minus so that we can make them positive, make it positive. Like this, here I have given the example. Suppose x is positive, it will be same as it is. X is itself negative. In place of x, I have taken minus 5. In place of x only, I have taken minus 5. So if you take the mod, then another minus I need to take, this minus. Then x is already minus 5, no? So minus of minus 5 will become again 5. This is the concept. So whatever the negative values also if you take, negative values also if you take the values less than 0, that means negative. Thereafter also this value will be positive. Okay, if any value goes to positive, negative, any value is, if it is goes to under mod, after coming out it will be always positive. Okay, any negative things also getting positive if it goes inside the mod. And obviously this fact, if x equal to 0, then mod 0 will be always 0. This is very obvious. If x equal to 0, mod 0 will be always 0. This is the definition of mod function. Remember very much carefully this concept, this definition is also useful. Mod x definition, okay, in calculus, very much useful, this one. So now let me draw the graph. You see, the graph will be like this. You see, this will be the graph. Now you see, first of all, you see, if I take with y equal to x, y equal to minus x, and y equal to 0, these three things we will draw. Now you take the positive values first. That means for x greater than 0, we'll draw the graph. Mod x equal to x, no. For x greater than 0, let us take the value greater than 0. That means I have taken 1, I have taken 2, I have taken 3, I have taken 4. Some values I have taken. Okay, so if 1, mod of 1 will be what? 1 only. That means y will be 1. That means you will get here. Mod of 2 will be what? As it is positive, it will remain again 2. Isn't it? That means y will be 2. Isn't it? So it will be like this. Mod of 3 is again positive, so it will be again 3 after coming out of the mod, so it will be again 3, so it will be like this. If 4, mod of 4 will be again 4. So if you take the positive values, y equal to x, already we have drawn in the identity function, fx equal to x, isn't it? So similar kind of graph. Okay, it will pass through the points. Okay, straight line. Now at x equal to 0, if I take x equal to 0, mod 0 is what? Again 0. That means at the point 0, this is getting you 0. That means it is coming here. So it is continuous at 0 as well. Isn't it? At the origin also it is there. Now I am taking the negative values. You see, suppose I am taking minus 1. So in the minus 1, what it will give? It will give, if I am taking inside the mod minus 1, it will give minus of minus 1, which will make it again positive. Again it will be positive. Again it will be 1. So at the point minus 1 also, the graph is giving 1. Y is positive only. Y will be always positive. Okay, because modulus of x, if x is negative as well, then after coming out of this one, it will be positive again. So if you take minus 2, so mod of minus 2 will be what? Mod of minus 2 would be equal to minus of minus 2. It will be again plus 2. So it will be plus 2. That means it will be like here. Similarly, at the point minus 3, it will be again minus 3. It will be again minus 3. In this way it is going. Now again if you join the point, so this is a V-shaped graph. This is a V-shape. You see, this is a V-shaped graph. This is the graph of mod function or modulus function, we can tell. I think you have got the concept. This is the graph of mod function. Remember the process I have drawn in front of you, okay, in this video. So through the points, through the concept here I have discussed, we can easily draw the graph. Okay, so remember the part. Then I am going to discuss signum function quickly. Okay, signum function, that is also important. Remember the thing, signum function. Signum function is just nothing. Signum function Signum. Okay, signum function. The definition is like this, you see, fx, okay, fx will be here, y is equal to, fx is equal to, means signum, sig we are denoting, signum of x, this is the function, signum of x. It's like mod of x we have written, no, in mod function. Now in signum function we will write signum of x. That means in the x, if you are taking the rule signum, here f we are taking, no, that f is here signum, that is the function of x. Means if I take f on x, we will get some element, no. So what type of element you see? What type of rule is this one, you see? Signum function definition is mod x by x. That means if you divide the modulus function with the identity function, it will give you signum function. That means mod x divided by x will give you signum function. So what it will be? Already we know mod x means what? Mod x will be x. Denominator is nothing. Denominator is x only. In place of mod x I have taken x. When x is greater than 0, no. Modulus of x will be minus x. If x is less than 0, no. If x is less than 0, already I have discussed. Denominator is x only. Mod x will be 0. Mod x will be 0. Okay, if x equal to 0, that means 0 by x, it will be again 0, isn't it? So these are the things. Now if I rewrite the function, if I rewrite this one, rewriting the function, fx will be equal to what? X by x will be 1, no. That means for x greater than 0, fx will be 1. That means y equal to fx will be 1. For x less than 0, it will be minus 1, no, from the calculation. And for x equal to 0, fx will be what? 0. So this is the definition of signum function. Remember, this is the definition of signum function. Now depending upon this definition, we will draw the graph. Okay, so let me rub that part. So signum function graph will draw here. You see, signum function, we have got this one. Now after getting this one, how to draw the graph? You see, this is the coordinate system. Now you tell me, fx equal to 1, this is the constant function, no? Fx equal to 1, that means at the distance y equal to 1, we'll get one line parallel to, like this, parallel to x-axis. So this is fx equal to 1, first graph we have drawn. But it will be for x greater than 0, no? So in the negative side it will not be there. And at, you see, at x equal to 0, this is y-axis. On the y-axis, x is equal to 0. So at x equality 0 is not there. For the values x greater than 0, that means at the value x equal to 0, we don't know what is there. Y equal to what, we don't know. Here we don't know. Here we know. At x equal to 0, y is 0 only. That means this is the point. At x equal to 0, y is 0. But at x greater than 0, if x the values are greater than 0, that means after 0, I am not telling 1. It may be 0.00001 also. If x is greater than 0, fx will be 1. How to denote this one? You see, you give one this kind of open circle here. This kind of open circle and draw a line like this. That means at the value 1. This is the point 1, no. For y it is 1, no. Because it is 1, no. Y equal to 1. So for x greater than 0, y will be 1. This is the line x equal to 1. Yeah, this is the line x equal to 1. Okay. Sorry, why I have written x equal to 1. This is y equal to 1. Sorry. Yes, y equal to 1. Now x less than 0, you see. For the values x less than 0, y equal to what? Minus 1. So we'll go minus 1 distance. That means it will be somewhere like here. This is the minus 1. This is y equal to minus 1. Now at the value x less than 0. X less than 0 means no, in this line x is 0. So here also you are supposed to give this kind of open circle. And you are supposed to draw like this. Because this is y equal to minus 1, no. So this one would be y is equal to minus 1. Okay, for x less than 0. For x less than 0 means in this side. For this, all these value you will get minus 1. For all these value you will get minus 1. For all these value greater than x you will get plus 1. Okay, this is the graph of the signum function. Okay, this look like this one. This point will be open circle. Okay, means it is not touching x equal to 0. It is not touching x equal to 0. After x means the values of x less than 0 and for the values of x greater than 0 I am having the graph, and at x equal to 0 we have seen that y is directly 0, so this is the point. So this is the graph of signum function. Similarly, the last one, that one is called greatest integer function. Greatest integer function, very important function. Greatest integer function, very important. So greatest integer function, the definition of the greatest integer function is fx equal to box x. In this kind of third bracket we will give, and inside the third bracket we will write x and we will read as box x. Okay, fx equal to box x. This is sometimes called box function as well. Okay, greatest integer function or box function. Okay, fx. So y equal to fx equal to box x. Now what is the definition of box x, or what is the definition of greatest integer function? This is the notation. Okay, definition is greatest integer less or equals to x, less or equals to x. This is the definition. Greatest integer less or equals to x. You see, very interesting fact. Suppose I am giving you box of 2.5. Box of 2.5. So box of 2.5 will be as the line goes, greatest integer less or equals to x. So less than this. Okay, less than this. What are the integers there? What are the integers less than this? We know this is 2.5. No, so less than 2.5 integers are like 2, 1, 0, minus 1, minus 2, minus 3, all these kind of things, like 2, 1, 0, minus 1, minus 2. These are the integers less than 2.5. Now they are telling greatest integer. Okay, so out of all the integers less than 2.5, which one is greatest? Greatest is 2. No, so greatest integer less than this x, less than x, that one would be equal to 2. This is the rule of calculating box function. Box of 2.5 will be 2. Similarly, tell me what would be box of 1.5? Box of 1.5. Similar only, greatest integer less than x. In place of x I have taken 1.5. So greatest integer, what is the greatest integer less than 1.5? So many integers are there. So many integers are there which are less than 1.5. This is not integer, this is 1.5, any number. Okay, this is a rational number. Okay, now 1.5, greatest integer of 1.5, less than integers. What are the things? 1, 0, minus 1, minus 2, in this kind of way. So out of all those things, which one is greatest? Greatest is only 1. So box of 1.5 will be 1, like this. So can you tell me what would be box of 0.5? Similar logic, greatest integer less than 0.5. So that one would be equal to 0, because the integers which are less than 0.5 are 0, minus 1, minus 2, minus 3. In this way it will go. No. So out of all these integers, which one is greatest? 0 is greatest. So in this way we will calculate. Now this is gone the concept less than. Now what does it mean equals to? When the equals to logic will come, you see, equals to logic will come in this case. If suppose I am giving box of 2, box of 2. Now here will come the logic equals to. What is the concept? You see, greatest integer less or equals to I have written. No, less or equals to. If it is integer itself, if inside the box there is integer itself, so that would be simply that integer. That's why equals to x. This is the concept of equals to, and this one was the concept of less than, because this is not integer. No, so we are supposed to write the integer which one is less than 2.5, and less than 2.5 there are so many integers. So out of all those integers we are supposed to write the greatest one. Okay, this is the difference between this box of integer and box of any number. Okay, any real number if I take. Okay, this is the difference. Okay, suppose you want to find 1.3. So what would be that? That would be also 1, because less than 1.3 greatest integer is only 1. Okay, this is the concept of greatest integer function. So let us draw the graph of this function. This function is very important. Understand this logic. Okay, so let us draw the graph of greatest integer function. So the graph is like this. You see, very interesting graph. You see, so as we know, box x, fx equal to box x. So can you tell me what would be box of 0? That means we are supposed to put 0 first, no? What would be box of 0? Obviously 0 is an integer, so it will be equal to 0. That means the point will be here only. Now I am proceeding from 0, after 0. Okay, now I will take the values from 0, because 0 already I have taken. Okay, 0 already I have taken. So after 0 till 1 I will go. After 0, I have given open interval there. After 0 till 1 I will go. You know about the concept of open interval and closed interval, because till 1 will go. Suppose this is the point 1. Okay, so let us see, shall we need to go till 1 or not? You see, at the point 0 it is 0. Okay, now you just increase the value. Now I am taking 0.2. It will be what? Again 0, isn't it? So value is again 0. 0 means here only, on the axis only. The value of y is equal to 0. No, let us not take this one, would not be closed, because I have started from 0. So closed in the 0. I have started from 0. So if I put x equal to 0, y is equal to 0 only, isn't it? Y equal to 0 only. Now I am increasing the value. Okay, now I am taking 0.2. If I take 0.2, so y will be what? Box of 0.2. It is again 0, because greatest integers are less than 0.2. So it is again 0. Now in this way I am increasing. So before 1, that means suppose I am taking 0.99 something. 0.99 something. So box of that one will give you what? This one will be again 0, no? So that means before 1, all the values will be 0 only, because when it will take the value 1, box of 1 will be again 1, no? Box of 1 will become 1. So I will go before 1. Okay, that means the graph will be from here, all the points I will take. All the points I will take, just I will not take 1. Okay, this is the first part. Then I have completed what? I have completed closed 0, open 1, like this. Now I will start from 1. Now at the point 1, at the point x equal to 1, at the point x equal to 1, box of 1 equal to what? Again 1. That means at the point x equal to 1, y would be also equal to 1. From here if I put at the point x equal to 1, y equal to, at the point x equal to 1, this one will be also 1. So at the point x equal to 1, y will be 1. That means we will get our point here. Okay, this is the point we got. Okay, let us not make this circle. So this is the point we got for x equal to 1. Now I am increasing from 1. Now I have taken the value 1. Now I am increasing from 1. Now suppose I have taken 1.2. 1.2. Box of 1.2. This one will give you what? Box of 1.2. Greatest integer less than 1.2. So it is 1. So at the point, if you increase the values of 1, before 2, this is the point 2. If we go before 2, all the values will be 1 only. Because if you take 1.99 also, that one will also give you box of 1.99 also 1. If you take 1.8 also, that one will also give you 1. Only at the point 2 it will change its value. Before 2, all the points, all the fractional points, starting from 1, before 2, all the points, box of all the points will give you 1 only. That means you will go in this way. Y will be 1. Before 2. Before 2. At the point 2 it will be 2. So before 2 it will be like this. Because at the point 2 I will not get 1. At the point 2 what I will get? At the point 2, box of 2 will be what? Box of 2 will be again 2. So at the point 2 the value will change. So you see, at the point 2 the value will change. So this is at the point 0. This is from the point starting from 0 to 1. This is the first part. Then I have taken starting from 1 before 2, because at the point 2 the value will change. At the point 2 the value will give you 2. So this is the 2. At the point 2 there you will get. Now before 3, okay, this is the point 3. Starting from 2, before 3, all the points will give you 2 only. Suppose 2.5, box of 2.5 also 2, box of 2.9, that one will be also 2. That means before 3, all the values, after 2, before 3, all the values will give you 2 only, all the time. So before 3 all the values will be 2, that means it will go 2 only. Before 3, at the point 3 there will be no, there will not 2. At the point 3 there will not 2, that's why I have taken the open circle. At the point 3 value will take 3 value, because box of 3 is equal to 3. Box of 3 is equal to 3. So in this way it will go on. Okay, in this way it will go on, step. That's why greatest integer function, sometimes it is called step function, sometimes it is called box function or greatest integer function, or it is called step function. You see, we are going step by step now, so that's why it is called step function. This one I have taken the positive values. Now if I go in the negative way, if you see 0 already I have taken there, now I will take less than 0, suppose minus 0.5. What would be the greatest integer of minus 0.5? Can you tell me? Minus 0.5, that means greatest integer less than this. So what are the integers less than this? Can you tell me? Less than 0, minus 0, minus is there, okay, minus is a little bit different. Minus 0.5, if you consider the number line, there is 0, this is minus 0.5, this is minus 1, this is minus 2, in this way it is going, no? So less than means less than minus 0.5, the integers are minus 1, minus 2, minus 3, in this way. So out of all the integers, which one is greatest? Minus 1, that means minus of 0.5. Minus of 0.5 will give you minus 1. Minus of 0.5 will give you minus 1. Similarly, suppose minus of 1.5. Minus of 1.5, that means greatest integer less than this. So less than minus 1.5, what integers are there? Minus 2, minus 3, minus 4, in this way. So out of all those, which one is greatest? Minus 2. So minus of 1.5 will give you minus 2. In this way we will put the negative values. So you see, so suppose this much. So as I have seen, if I take 0.5 also, x equal to suppose 0.5, this is 0.5, this is 0.7, this is 0.8, in this way, minus all the negative values. I'll get what? For all the values I'll get minus 1. No, I'll get minus 1 starting from not 0, after 0, that means open 0, after 0. Okay, that means in that side. So let me take in this way, minus 1 and 0, because 0 is greater, no, and I am taking the value minus. I am taking the value minus 1. Is that it? So this one will be like this. So if you take minus 0.5 also, that one will give you minus 1. That one will give you minus 1. And at the point minus 1 also it will give you minus 1. So it is giving you minus 1. At 0 I don't know. But less than 0. At 0 I don't know. Okay. So at 0 we will have this open circle. Because I am giving minus 1. Because we will get minus 1. No. So y is minus 1 there. This is y equal to minus 1. So it will be like this. It will be like this. Till, because this is 0. Suppose this is minus 1. Till minus 1 it will come like this. Till minus 1. It has not taken the value 0. Because open interval at 0. Now if I take minus 2 and open at minus 1, now I will not take minus 1. After means less than minus 1, suppose minus 1.5. Suppose minus 1.5. That one will also give you minus 2, no? Minus 1.8. All the things will give you minus 2. And at minus 2 also it will give you minus 2. So it is just the opposite of the positive values. So this is suppose minus 2. So at the point minus 2, obviously it will give you minus 2, and at all the values after minus 1 means less than minus 1, so it will be in this side, minus 1.5 suppose. So at minus 1 there will be open, because all the things will give you minus 2. So this is y equal to minus 2 suppose. This is y equal to minus 2. So come in this way. So here there will be open circle at x equal to minus 1, just equal to that. So previously it was still minus 1 was there, but at minus 1, this one means after minus 1, I will not take at minus 1, because at minus 1 it was minus 1, no. So after minus 1, because minus 1.5, that one will give you minus 2. So after minus 1 I will take, that means all the things will give you 2, till 2 it will come like this. You see, this is the graph. So in this way it will go. Similar for 3, if I extend the line, suppose this is minus 3. So in this way it will come, it is minus 3, so minus 3 will be 3 minus 3, so at that time it will also extend this one y equal to minus 3. At that time from here open circle will start and till 3 it will go like this. So you see these are the steps, no, step step step, so that's why it is called step function or greatest integer function. Very important function, try to remember this one. And greatest integer function, and remember the definition, greatest integer less or equal to that. Suppose box of x I have written, that means greatest integer less than x, greatest integer less than x. So this much only. So here I have discussed 5 functions. Okay, so what are the things? Identity function, constant function, modulus function, signum function, greatest integer function. Okay, so remember the functions, remember the graphs of the function, definitions also, mainly modulus function, greatest integer function, definitions. Try to remember how to break mod function, that one is very important. Mod x equal to x if x greater than 0, mod x equal to minus x if x less than 0, mod x equal to 0 if x equal to 0. This definition try to remember. Okay, so here only I am completing this video. Okay, types of functions. In my next video I will try to discuss about the domain and range of real functions, not for relations. Okay, not for relations, how to find some function will be given, how to find the domain and range of that function. Okay, thank you.